All right, welcome back. So I need to add here at this joint, there's a 3,000 pound load hanging down, which it didn't come into play when we summated moments about L because its line of action goes through L and it didn't create a moment. But I need to put it on there now. It's 3,000 pounds. Because my next choice is to summate moments about A. And the reason I chose that is because the line of action of this force, it's an unknown at this point, but it passes through A. So I can eliminate it as a moment, causing member force. And force BC, we already know what it is. It's over here, it's 10,000 tension. But anyway, it doesn't come into play either. When you summate moments about A, the only things that come into play are this 3,000 pound force, and then the X and Y components of this member. So we can solve, by summing moments about A, we can solve for FLC. So let's do that. So starting with the 3,000 pound force, it causes a negative rotation about A with a moment arm of 4 feet, and FLC has an X component that causes a negative rotation. The X component is the X component over the hypotenuse, so 4/5 FLC. And then FLC also has a vertical component up and down here that is going to cause also a negative rotation. And the vertical component is 3/5 FLC. Oops, I better do a moment arm for this. This X direction has a moment arm of this vertical distance of 3 feet. And then the Y component is 3/5 FLC. And its moment arm is 4 feet. So, anything else? That's it, equals 0. We can solve directly for FLC, and when you do the math, you end up with a negative number. And you end up with a negative 2,500 pounds. So, we assumed that FLC was positive tension, come up with a negative. As it turns out, it's not in tension, it's in compression. And box it. Compression. All right. 2 out of 3. So how can we get our, what else remains? FBC we got, FLC we got, FLK I want to show you something. We can get FLK also by summing moments about a point that's not even on this truss. See, here's point C over here. But we've made our cut. So point C is out here. It's not even, I mean, it's on our truss, but it's not really on our section, but it is out here along about right here. Here's point C. Well, you can sum moments through any point that's on the truss, whether or not it lies on your section. And if we do that, then we eliminate, because both FBC and FLC, the line of action of those forces passes through point C, then we can solve directly for the X and Y components of FLK. So let's do that. That's a pretty cool trick. So let's see how it works out. So let's summate moments about C equal to 0. Make that positive again. And what do we got? So we got the 3,000 causes a positive rotation about C, and its moment arm is, this is like way stretched out, but that's actually 4 feet right there between those points. I've just drawn it exaggeratedly. So its moment arm is 4 feet, and the 7,500 pound causes a negative rotation with a moment arm of 8 feet. And then the X component of FLK causes a negative rotation about C. So a negative, and the XLK, the X component is 4/5 FLK, and its moment arm is this vertical distance, 3 feet. And then the Y component also causes a negative rotation about C, and the Y component of FLK is 3/5. And its moment arm is this horizontal distance, 4 feet, equal to 0. Solve for FLK, and you come up with another negative number, magnitude 10,000 pounds. It came out negative. So the ruling on the field is reversed. We assumed it to be positive tension. Instead, we're in compression for this member as well. So by using the method of sections, you don't have to go joint by joint. You can just cut into whatever members that you want to solve for. And when you decide, so you decide, here's the steps we just went through. Decide how to cut the truss, and cut through no more than 3 members. And the reason for that is because you just have 3 equations of equilibrium. We only used summing moments for this problem. We still had 2 more equations available that we could have used. Then, secondly, first we decided how to cut, then we determined the support reactions if necessary. It was necessary. And then we drew the free body diagram of the section. And then we applied our equations of equilibrium. And remember that when you sum moments about a point, you can choose that point to your advantage. If it's at the intersection of 2 unknown forces, you eliminate those 2 forces from your equation.